In order to determine the elevation of the top of the lighthouse T on a hill, the following observations are made from two instrument stations A and B, which are 95 meters apart. The top of the lighthouse and stations A and B are in the same vertical plane. The angle of elevations to the top of the lighthouse from A and B are 28 degrees 30 minutes and 19 degrees 45 minutes respectively. The staff readings on the benchmark from A and B are 1.325 and 2.755 meter respectively. RL of benchmark is 202.450 meters. Determine the elevation of the top of lighthouse T. Draw the figure using the given data. The instrument is initially set at A point and it is observed the vertical angle to the top of lighthouse T, which is 28 degrees 30 minutes, and backside reading on the benchmark from A is 1.325 meters. Later the instrument is shifted to B point, which is 95 meters away from A. From B, vertical angle observed to the T is 19 degrees 45 minutes and backside on the benchmark is 2.755 meters. Let's assume the horizontal distance between A and lighthouse is D. Backside reading from instrument at A 1.325 meters. Vertical angle observed from instrument at A to top of the lighthouse T is 28 degrees 30 minutes. Backside reading taken on benchmark from instrument at B is 2.755 meters. Vertical angle observed from instrument station B to the lighthouse top T is equal to 19 degrees 45 minutes. The horizontal distance between A and B is 95 meters. This is H1. The vertical distance between instrument axis at A to the top of lighthouse is H1, and assume the vertical distance between the instrument axis at B to the top of lighthouse is H2. So it is A dash, this is B dash, this is T dash, T double dash. Let's observe the figure from triangle A dash T dash. We can write tan 28 degrees 30 minutes is equal to H1 divided by capital D. Therefore D tan 28 degrees 30 minutes is H1. H1 is equal to 0.542 D. So this is question. From triangle B dash T dash tan 19 degrees 45 minutes is equal to H2 divided by 95 plus D. Therefore H2 is equal to 95 plus D into tan 19 degrees 45 minutes. 95 plus D into this value is 0.359. Therefore H2 is equal to 95 into 0.359 plus 0.359 capital D. H2 is equal to 34.105 plus 0.359 D. So this is second equation. From the figure, if you observe the difference between H1 and H2, this distance, vertical distance, is equal to the difference between these two staff readings. H1 minus H2 is equal to 2.755 minus 1.325 meters. H1 minus H2 is equal to 1.430. So this is 3. From 1, 2 and 3 you can write H1 is equal to 0.542D minus H2 34.105 plus 0.359D is equal to 1.430. Therefore 0.542D minus 34.105 minus 0.359D is equal to 1.430. 0.542D minus 0.359D is equal to 1.430 plus 34.105. The difference between these two is 0.183D is equal to 35.535. D is equal to 35.535 divided by 0.183. Therefore D is equal to 194.18318 meters. This is horizontal distance between A and T. Capital D is equal to 194.180 meters. Now substitute this D value in H1 or H2. We know H1 is equal to 0.542D. 0.542 into D values 194.180. H1 is equal to 105.245 meters. Substitute the D value in H2. H2 we know 34.105 plus 0.359D. H2 is equal to 34.105 plus 0.359 into 194.18. H2 is equal to 103.815 meter. We can find out the RL of top of lighthouse in two ways. By using H1, we can write the RL of top of lighthouse as, considering the instrument at A, RL of top of lighthouse is equal to RL of benchmark plus backside reading taken from A is 1.325 plus H1. Benchmark RL is 202.45 plus 1.325 plus 105.245 meters. RL of top of lighthouse is 309.020 meters. Considering the instrument at B, RL of top of lighthouse T is equal to RL of benchmark plus backside reading taken from B plus H2. Benchmark RL is 202.45 plus backside from B is 2.755 plus H2 is 103.815 meters. RL of top of lighthouse T is equal to 309.020 meters.